Okay, in this section we are going to talk about heat, H-E-A-T, heat, and we'll learn about these questions. What is heat and when does it happen? How does it flow? And the rise in temperature always caused by heat. Okay, first thing first, have a look at the definition. Heat is the energy transferred from one body to another due to the temperature difference. Okay, it has to fulfill all these three characteristics. By definition, it will fulfill all of these. What does it mean to be from one body to another? Okay, imagine there is a hot object, there is a cold object. Heat will flow from the hot one to the cold one. This flow of energy due to temperature difference is called heat. But sometimes you will hear sentences like this, which is wrong. Someone will say, okay, an object has more heat at high temperature. This is not correct. The concept that he wants to deliver is that the object has more internal energy at higher temperature. But it is not heat, because if you are talking about one object alone, there is no heat. This energy that indicates how much it carries is internal energy. When in physics, when we use heat, this particular term, it always refers to the flow of energy from one object to another. Okay? For example, in this experiment, I believe this is wrong. Since it is cold and it is hot, there should be a difference in the reading. Okay. Heat will flow from the hot tea to the cold water bath, and after a while, you will observe the tea become less hot and the water will warm up. Okay. So now you know it has to be the flow from hot object to cold object. We will talk about why it happens. Okay, on the top left hand corner here, you can see, let me use a red circle to indicate a fast moving molecule vibrating at higher speed, and this blue one indicated is slower, moving slower. But when these two molecules are next to each other, maybe on this surface between A and B, the fast moving molecule will bump into the slow moving molecule, and kinetic energy will transfer from the collision. The fast moving object will slow down a bit due to the loss of kinetic energy, and the slow molecule will speed up due to the gain in kinetic energy. Okay, molecular level, that is what happens. And then this, after losing some energy, it becomes less fast, and this slower object, this slower molecule will gain speed, and this will continue to happen. It will go slower, the fast one will slower and slower, the slow one, it will go faster and faster. When will it stop? When they have reached the same speed, then even they collide with each other, there will not be a significant change in their level of kinetic energy, right? So this is what the yellow box try to convey, try to tell us. The heat flow will continuously happen until their temperature become the same. They have the same temperature. Okay, we have a special term to describe this situation. It is called thermal thermal equilibrium. Okay, this term you have to learn, but it is not so difficult. Thermal is related to 溫度. Okay, thermal equilibrium. Equilibrium 平衡狀態 you can see equal in here. Not exactly the same, not EQUAL, equilibrium. Have I spelled it wrong? I'm worried. Equilibrium. Okay. Equilibrium is correct. I'm sorry about that. I am professional. I should not worry about wrong spelling, but I have to check so that you know it is correct. Equilibrium, EQUILIBRIUM. It means same temperature. Okay, 一樣嘅溫度。Thermal equilibrium is same temperature. Okay. So heat will continue to flow until it reaches the same temperature. At this stage, we call it thermal equilibrium. But before this same temperature status is reached, there is always heat flow. And the direction of the heat flow is important as well. Always from hot to cold. What does it mean? For example, you have a cup of hot coffee on the top. Then from hot to cold, let's say your coffee is 60 degrees Celsius or 70 degrees Celsius. It is hot and the environment is cold, maybe 20. Okay, so heat will flow from hot object to cold object, which is from the hot coffee to the environment. For example, I have set at 70 degrees Celsius to maybe 20 degrees Celsius, okay? And then another case, if you get the ice cream from the fridge, the ice cream is cold and the environment is hot compared to the ice cream. So the direction of heat flow is from the environment into the ice cream. This is the heat flow. And as an example, maybe the environment is still 20 degrees Celsius, but maybe the ice cream is 4 degrees Celsius, okay, or lower, whatever. So the direction of heat flow is always from hot to cold and never the other way around. And then next question, if there is an increase in temperature of some object, does it mean it is caused by heat flow? No. An example is that in the winter, you feel very cold. Your hands are very cold. You want to keep warm, right? Let's say this left hand is 20 degrees Celsius and the right hand is also 20 degrees Celsius, which is very cold for a body temperature. And then you rub against each other. And then maybe it rises from 20 to 25, okay? Let's say it should be warmer. I have chosen too low value. And whatever, stick with it, sorry. Okay, the initial temperature of both hands is the same. So where does the temperature rise come from? There is not a heat flow. Heat flow is always due to temperature difference, but 20 and 20 together get to 25. This is obviously not heat. Okay, heat is from hot flow to cold. This case we call it work, doing work. This is also a term from physics. Work is 作工. No, do is 作. Work is 工. Okay. That is not an explanation at all. Okay. What you have to know is that when internal energy increase, there is two main ways. The first one is heat. Is the fast vibration influence the slow vibration or other form. This is the heat. There is the energy transfer from hot object to cold object. But there is another way doing work. For example, in rubbing your hand, the mechanical energy due to the movement is in this action transferred into the internal energy of the molecule of your hand. It turns to the average kinetic energy of the skin surface vibration and so. So these type we classified as doing work. Another example you can play with paper clips, 萬字夾. You can get a paper clip and then you bend it and then bend it back and then you bend it again. After several times of stretching, compressing, bending, and then you will find that the temperature of the paper clips rises. It will get warmer, and if you keep doing so, there is chances that it will break, but you can still feel that it gets warmer. The mechanical energy due to your movement is changed into the average kinetic energy of this object, so it gets warmer, but not due to heat. It's due to doing work. Okay, so there is a lot mentioned in this video already, so let's sum it up. What is heat? Heat is the energy transfer from one object to another due to temperature difference. Temperature difference is the key point here. There has to be temperature difference. And so for when does it happen, the answer is when there is a temperature difference, there will be a heat flow. The heat will flow when there is a temperature difference. And in other words, when there is temperature difference, there will be heat flow. So when there is no longer any temperature difference, there will not be heat flow. And for no temperature difference, the terminology we have to learn is thermal equilibrium. Okay, when the two objects reach thermal equilibrium, it means they have the same temperature. There will no longer be any heat flow. Okay, and the direction of heat flow is always from hot object to cold object. So in these two examples, the coffee is hot, so heat flow from the coffee to the surrounding, and the ice cream is cold, so heat flow from the environment into the ice cream. Okay, from hot to cold. So now that you have learned physics, you know what flowing is the heat energy. So never again say that, oh, this pen is cold, I feel the coldness flow into me. That is not physics. That is wrong. What you feel, what you can say when you feel something is cold, it is that the heat flow from your hot hand into the cold pen. So this loss of energy is what you feel to be cold. Okay, and then the last bit is, if there is a rise in temperature, must it be caused by heat? And the answer is no, because there is two main ways to increase the internal temperature, internal energy. That is, one is the heat transfer. We will use Q as a symbol to indicate, and the other is called doing work. So when there is rise in temperature, not every time is caused by heat. It can be doing work. For example, you rub your hand or you play with the paper clip. This is not heat flow. This is do work. Okay, and there are a lot mentioned, and if you find it difficult to catch every bit, maybe you will have to rewatch some bits of this video. And thank you for listening.